Oh, hang on. Okay, the sine graph, if you do the same thing, if you look at the sine graph, I'll just draw it down here for the sake of time, right? It goes up, the first part it goes up, because the y coordinate's positive. So the sine is positive in quadrant 1. Then it starts to decrease back down to 0. It's still positive though in quadrant 2 because the y coordinate is positive when you're above the axis. This follows the y coordinate. The y coordinate is positive when you're up here anywhere, and it's negative when you're down below. The next part of the graph, the sine goes negative and it stays negative. That's why those are both negative there. You learned this in grade 11, but probably you just learned it as a memorizing thing, right? What did you learn in grade 11 trig to help you remember that? You either learned it as, you either learned this, or you learned all students take whatever, chemistry, calculus, whatever you want to put in there. You may have made up maybe you made up your own thing. You maybe didn't understand why all the ratios were positive in quadrant 1. They're all positive because both the x and the y coordinate are positive in quadrant 1. And then sine is positive in quadrant 2 because it follows the y coordinate, and that's positive in quadrant 2. And then cosine's positive in quadrant 4 because it follows the x coordinate, and that's where it's positive. Sine follows the y coordinate, that's where the y coordinate's positive, above the axis. Whereas cosine follows the x coordinate, and think about where that's positive. The x coordinate's positive over here, right? Because you're going that way. The y coordinate's positive over here this way, right? For tangent, we haven't looked at tangent, but you can make the same case for tangent. Tangent is actually, in the triangle, is going to be, just think about this anywhere. Tangent is y over x, opposite over adjacent. So it's a little bit more tricky. You have to look at how the signs are paired up. When these signs are the same, that's where tangent's going to be positive. When those are the same. When they're both positive or both negative. So here, where's the other place tangent's positive?
3.
That was quick. And I hadn't even finished asking the question. There's the other place where it's positive because they're both negative there. That's getting a bit ahead of ourselves here, though. All right? Finding the angle given the point on the terminal arm. You can work backwards from this. I don't know why I put a little dot here for this to help you, because I didn't think you were capable of finding the point -2, -1, I guess. If you know the point on the terminal arm, this is where it helps to know the words, right? Terminal arm means where it ends. It starts here, and it goes around to a line that has this point on it. Okay, so there's a line that has that point on it. There's the angle we're looking at. We're going to use the reference angle. You're going to use the reference angle to kind of set this up here. Okay? The calculator, if we're using the calculator, doesn't find angles in other quadrants. The calculator always finds an angle in quadrant 1 if you put a positive number in, or some other quadrant if you put a negative number. If you use the inverse function on your calculator, this is what it finds. If you do sine inverse or cos inverse or tan inverse of a ratio, it gives you an angle in quadrant 1. Those numbers, those things take a ratio. You know what I mean by ratio, right? Here's one that you should know. Sine of 30 degrees is, what's the sine ratio for 30 degrees? 0.5. That one happens to be, because when you draw a triangle with a 30-degree angle, this is 1, this is 2. This happens to be a 1-to-2 ratio. This is something you're going to have to learn in the next thing here anyways, but so if you don't know it. But if you use the sine button, let me demonstrate on the calculator here. The virtual calculator. If you're using degrees, you have to be in degree mode. If you're using radians, you have to be in radian mode. If you're not using these trig buttons, it doesn't matter what mode you're in. So if I'm going to put in a degree, if I'm going to put an angle in degrees here, if I do sine of 30 degrees, it gives me 0.5. That's what this button here does, sine or cosine or tangent. What it does is it takes the angle. I should actually make some space here, and you should write this down somewhere. You can whine all you want, but that's what you should do. This button and the cosine and the tangent button, they take an angle like 30 degrees. You put it in and push that button, and what did you say it gave me?
0.5.
It gives you 0.5. This is the angle. This is the ratio for that angle. Okay? So we have, this thing takes, this button takes the angle and gives you the ratio. If you want to go backwards now, what button lets you go backwards and take a ratio and give you the angle back? Sine inverse. It's just like any other buttons, like this button on your calculator. It has an inverse, right? We've talked about what inverse is. Inverse is just the operation that undoes that. The inverse of squaring something is square rooting that thing. Those are inverse buttons. These are inverse buttons because they undo it. It takes the ratio and gives you back the angle. I'm not trying to insult your intelligence in that you already know this, but so if I do sine inverse of 0.5, it's going to give me back the angle. The problem is if I do an angle it isn't a one-to-one correspondence between things, right? There's lots of angles that have a sine ratio of 0.5. There's this one, 30 degrees, or there's this one, 390 degrees, or there's one in this quadrant, there's 150 degrees. So let's do all of those just to prove to you here. Sine of 30 degrees, sine of 150 degrees, sine of 390 degrees. There's lots of different angles that have a sine ratio of 0.5 because they all end in one of those two spots. If we ask it to go backwards now, which one does it give you? That's the problem, right? It gives you 30. It gives you the smallest positive angle if you put a positive ratio in. If you put a positive ratio in, it gives you a quadrant 1 angle. All three of these buttons do. Because it works this way. 30, yeah, that's 0.5. 150, yeah, that's 0.5. 390, that's 0.5. But if you ask to go backwards, well, which of these three angles are you going to give me? It can't give you all the angles. It gives you the smallest positive angle. So it gives you the quadrant 1 angle when you put that in. So if we want to work backwards now and we look at what the trig ratios are here, the buttons isn't going to give you that angle directly. But what you do is you just pretend that you're using this angle and then use it to find the actual angle. Okay? If you want to find the angle here, write an equation for the ratio that goes with that angle. We're going to use the coordinates of the point here. Okay? Here's the coordinates of the point. What are the coordinates of the point? What are they giving me here? -2, -1, right? You could label it on your triangle here. -1, -2. And we're going to think really hard and see what goes on this line right here. No, you should be able to do this. This is Pythagoras you learned in grade 8. You should be able to do it in your head now, right? Here's you doing some thinking. Okay? You're thinking about a right angle triangle that has this. 1, 2. How long is this? This is what you're thinking about here. You can ignore the negatives when you're using the Pythagorean theorem, right? I know some of you are good at doing it's not 3. It is not 5. Yeah, it's square root of 5. It's 1 squared plus 2 squared. It's not 2.5. 1 squared plus 2 squared equals whatever this is squared, right? R squared. Thank you. Okay. You could, well, you can say that r squared is 5, right? If you don't have a calculator, what you can say is you can say r is the square root of 5 and just leave it like that. I think that's a good idea here for exact. This is an exact value. If you put it as a decimal, it's approximate, 2.23, whatever. It's easier to leave it as an exact value. So I'm going to call this root 5. This is thinking. This is not what you write down. I don't care about the grade 8 work here. You can do that in your head. If you really want to write it down, you can. There's nothing wrong with that.